Assalamualaikum warahmatullahi ta'ala wabarakatuh. We are from Group Euler and welcome to our project, which is Falling Body from a Tall Building. Introducing the Euler's group members. My name is Aiman Husaini bin Azmi.
My name is Muhammad ALIF IMRAN bin Muhammad ZAKI.
My name is NURIKMAL HAZEEM bin AHMAD FIZDRI.
We will start with the introduction. For the background of our project, a freely falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. Objects thrown outward or downward and those released from rest are all falling freely once they are released. Any freely falling object experiences an acceleration directed downward regardless of its initial motion. When force is applied to an object, it accelerates it, changing its velocity and position until another force stops it. These events are random, and we could focus on the patterns to better understand the concepts. First order differential equation ODE is a method that can be used in order to calculate the problem given. For our objective, it is to model a falling body with a differential equation and solve a falling object problem. We are also going to determine the velocity and time affected by gravitational acceleration by studying the position of a falling body. Our objective also is to be capable of using the ODE methods to solve a real-world problem and thus knowing how to use mathematical arithmetic in situations that aren't related to our studies.
Next, we will look at the mathematical formulation. So we consider a falling body with gravity acting on it and air resistance proportional to the body's velocity. The body is subjected to two opposing forces. The weight W equals to mg equals the force due to gravity, and the force due to air resistance equals negative kV. F equals to mg minus kV is the net force. So basically, this is our main problem. A 128-pound body is dropped from 1,000 feet with no velocity. Air resistance equals V over 8 in pounds as it falls, where V is the body's velocity in feet per second. Determine the body's limiting velocity and the time it takes to contact the ground. Next, we will show you how to solve this problem manually. Next, we will show you how to solve this problem by using a computer.
Okay, for computer-aided solution, we will be using Python at Jupyter Notebook. Firstly, we will import SymPy as we will be using SymPy to solve our ODE. Then we will list all our variables like time, velocity, and constant. After that, we will put our differential equation using the function EQ and set it as diff EQ and display the equation. Then we will solve the equation in terms of V using function dissolve. Now we have the equation Vt equal to C e power of negative 0.03125t plus 1024. Using the initial value given, we will find C. We will use the function v subs to substitute the value v and t in the equation. Then we will get C equal to negative 1024. That we will need to find the limiting velocity. For this part, we will be using the function sp.limit and set the limit at infinity. Thus, we will get the limiting velocity, which is 1024. Then we integrate vt to get displacement in st using function sp.integrate. Then we will get st equal to c plus 1024t plus 32768.0 e to the power of negative 0.03125t. Then we use the function integral.subs to substitute s equal to 0 and t equal to 0 to get c, which is we get negative 327868.0. Finally, we plug in the st values, which is the initial height, and we will get the final solution, which are the same as the manual solution, which is 1000 equal to 1024t minus 32768.0 plus 32768.0 e to the power of negative 0.03125t. So that's all for the computer-aided solution. So this is the graph that we get after we plot the graph in Python. The conclusion, a falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. When force is applied to an object, it accelerates it, changing its velocity and position until another force stops it. First-order differential equation is a method that can be used in order to calculate the problem given. Okay, so for recommendation, we only have one recommendation, which is before starting to do the manual solution, make sure that all the units in the mathematical model are correct. For example, if we use the unit height in feet, then the velocity must be in feet per second. Seems like gravity, we also need to use feet per second. This is the list of reference that we use to complete our mini project.
Okay, so that is all from our group. Thank you for watching.